Week 14, Tiger Jumpstart, Thursday. Number 1, divide 2 divided by 1 and 1/4. Remember, when you divide mixed numbers, you need to do backwards C, but we're going to rewrite the problem from left to right. So I have 2 over 1 divided by, now if I do backwards C, 4 times 1 is 4, plus 1 makes 5. So that's 5 over 4. From here, keep change flip. 2 over 1 times 4 over 5. You get 8 over 5, which is improper. So you would need to do long division. 8 is your dividend, 5 is your divisor. 5 goes into 8 one time, and 8 minus 5 would be 3. So we have a remainder, we can make the letter J. So you have 1 and 3/5. Number 2. Nasir paid $32 for 12 gallons of gasoline. To the nearest cent, how much did 1 gallon cost? Remember, to find one of something, you're going to divide. So we are doing $32 divided by 12. 12 cannot go into 3. 12 goes into 32 2 times. 2 times 12 would be 24. And subtract. 2 minus 4 we cannot, so 3 becomes a 2, 2 becomes a 12. You get a remainder of 8. But since we're dealing with money, I don't want to make the letter J. So let's change it into a decimal. Add your decimal, bring it up. Add your 0 and bring it down. From here, 12 goes into 80 how many times? Should be 6 times. 6 times 12 would be 72. Subtract. 0 minus 2 we can't, so 8 would be a 7. 0 is a 10. 10 minus 8 is 8. Again, we're going to have to add another 0. What do you notice is happening? It's going to keep repeating. So if you notice, I put another 6. That would make a 72. I still get a remainder of 8. I would add another 0 and bring it down. However, since we have all of these repeated values, I need to take it to the nearest cent. So in other words, remember, whenever you talk about money, you need to go 2 decimal digits past your decimal. So underline this 6. If I were to round this, would I keep it as $2.66 or bump it up to $2.67? It would become $2.67. Number 3. Which value represents temperatures at or below 2 degrees below 0 Fahrenheit? So think about a vertical number line. Here is 0. Here's -1. Here's -2. Then I'd have -3 and so forth. I either want to be at or below 2 degrees below 0. If I'm 2 degrees below 0, I'm currently at a -2. So think about what numbers or values are either at a -2 or they are below a -2. We know a -3 would work, so circle A. On B, -1.9. Think money. This would be like owing somebody $1.90. If I go over here, this is owing somebody $2. This is owing somebody $1. $1.90 would actually be right in here, right before you get to your -2. So that is actually above and not below. On C, a -4.2. Since I see the whole number is a -4, I know that is below a -2. D and E are both positives, so we would get rid of them. Number 4. Kirsten answered 9 out of 10 problems on a math test correctly. What percent of the problems did she answer incorrectly? So you have 9 out of 10 equals percent out of 100. Now remember, this 9 represents what she had answered correctly. The question wants to know what she answered incorrectly. So let's figure out what she answered correctly first. Let's put our variable and cross multiply. 10 times m would make 10m. 9 times 100 would be 900. You want m on its own, so you would divide both sides by 10. 900 divided by 10 gives you 90. So we know that m, which is your percent, is 90%. Now remember, this 90% goes with the 9. Well, what was the 9 talking about? The problems that she solved correctly. So how would I know what percent she solved incorrectly? So again, if she solved the whole test, that's 100%. If I take 90% of it away, which is what she solved correct, what that leaves me with is what she solved incorrectly. So you're doing 100 minus 90, which gives you 10. So 10% of her test was incorrect. Go ahead and put your jump start in your folder or your binder. If you know that you're going to lose it, then go drop it off. Just make sure you pick it up tomorrow before you enter class, or as you enter the classroom. Then when you're ready, go to page 167. So right now, go ahead and pause the video to make sure all students are prepared, and then click play. Page 167. You're looking at Topic 3, Lesson 7. In this lesson, you will simplify algebraic expressions by combining like terms. So if you look at your I can statement, today you will be able to combine like terms in algebraic expressions. Now this is something we actually kind of discussed yesterday. Look at the solve and discuss it. Write an expression equivalent to x plus 5 plus 2x plus 2. So let's think back on yesterday. Remember whenever we were doing distributive property? And if you had a number outside parentheses, you multiplied it by everything on the inside of the parentheses? Okay, this is kind of similar. We also talked yesterday about combining like terms. So let's review what a term is. Remember, a term are all my values that are left over when I take out my addition or subtraction operations in an expression. So for this problem, if I take away all these addition problems, or all my addition symbols, everything that's left over is called a term. A like term means that you either have the same variable, or you might just have numbers on their own. Okay? So if I'm looking at solve and discuss it, we're going to go ahead and jump right into this for combining like terms. If you look at your solve and discuss it, you have an x and a 2x. These would be like terms. So remember, if you have a variable but no number in front of it, put a 1. So right now I have a 1x plus a 2x. That would make 3x. Then I want to get rid of them. I'm going to drop down the next operation, which would be a plus sign, get rid of it, and then figure out what's left over. I have a 5 plus a 2, which will be a 7. So an expression that's equivalent would be 3x plus 7. Look at page 168. Remember, if you see something in yellow highlighted, it means it is a vocabulary term. So terms that have the same variable, part, such as y and 2y, are like terms. To simplify algebraic expressions, use properties such as distributive and associative, commutative, things like that, in order to simplify your expression. Okay? Look at page 168, the example 1, try it. I don't want to fill in all these boxes. I just want to look right here. If I said, hey, I need you to create an equivalent expression by combining your like terms. So remember, if you take out all your addition and subtraction signs, everything that's left is a term. If you notice, every term that we have all has a z. So we can combine these. Okay, so let's start here. We have a 4z minus a z. Remember, if you have a variable with no value in front of it, put a 1. So 4z minus a 1z would make a 3z. Okay, go from here. Then I have 3z plus 1z. That would make 4z. My final step would be 4z minus 2z, which makes a 2z. So my simplified expression is just 2z. Look at the convince me on example 1. How do you know that the expression 2x plus 4y is not equivalent to 6xy? Okay, so the thing is, when you combine like terms, remember they have to have the same variable. So you cannot just put the x and the y together and make an xy. So how do we know that they're not equivalent? We would say the terms must be the same when combining. Our terms must be the same when combining. Go ahead and look at page 169. If you were given 1/2 n plus n plus 1/2, how would you solve this? So remember, you want to combine your like terms. So like terms are when you take out your addition and subtraction symbols and everything that's left over. So our terms are 1/2 n, n, and 1/2. Do you see any like terms? These two are like terms because they both have the variable n. What would be in front of this n? A 1, so put a 1 there. Then go ahead and combine those. So add your whole numbers and your fraction. What is 1 whole cookie plus half of another cookie? 1 1/2 with the variable n. Now remember, you don't write n twice. You're just combining them into 1. Plus, all that you have left over now is your fraction 1/2. Now, even though you see a half here and a half here, you cannot add those together because this 1/2 does not have the variable n. And it's also a whole number over here. This is 1 1/2, not just 1/2 on its own. Go ahead and go to page 170. Look at question number 1. Do you understand? How can you simplify algebraic expressions? To simplify algebraic expressions, you combine like terms. Number 2, explain how you know which terms to combine when combining like terms. When combining like terms, you combine the terms that have the same variable. Okay, remember also, some of your terms may not have a variable. So also combine terms with no variable. Number 3, explain why the expression 2y minus y can be written as just a y on its own. So if you were given this, write this down please. What do you know is going to go in front of this y? Remember, if you don't see a value, put a 1. Solve this because they have the same variable. What is a 2 minus 1? That would be a 1 with what variable? A y. Now think about it. If I gave you just a y on its own, how is that the same as a 1y? Because variables on their own technically have a 1 in front of them. Remember, that number in front of the variable is called a coefficient. Let's put that. I'm running out of room. There you go. Variables that stand alone have a 1 as a coefficient. Number 4. Explain why the expression 1/2 x plus 1/2 x and just x on its own are equivalent. So again, if you have 1/2 x plus 1/2 x, you have combined terms that you can put together. So a half of a cookie plus another half of a cookie would make one whole cookie with the variable x. How is this similar to just x on its own? It would be the same as what we said for number 3. Look at number 5. Henry wrote 4z squared minus z squared as just the answer 4. So are 4z squared minus z squared and 4 equivalent? So again, if you had 4z squared minus z squared, think of it like this. Z squared is my like term, right? I need to put a 1 in front of that z because I don't see a coefficient. 4 minus 1 will give me a 3z squared. Therefore, these are not equivalent. Not equivalent as in Henry thought that 4 was the answer for 4z squared minus 1z squared. But the correct answer is just 3z squared. All right, let's move on. Number 6. On 6 through 15, we are just combining like terms so that we can simplify the expression. So remember, if you don't have a coefficient in front of your variables, then put a 1. Remember, coefficients are the numbers in front of your variables. All of these are like terms because they all have the variable x. So we're adding 1 plus 1 plus 1 plus 1, which gives you 4x. Number 7, put a 1 in front of your y. A 4y minus a 1y would make a 3y. Number 8, underline your like terms. So you have a 7y minus a 6y. This one does not have a y, so it's not part of those two. 7y minus 6y would make 1y. Remember, I could just write a y because you should know that technically there's a 1 in front of it. Then get rid of your values and do minus 4 5/10. Number 9, combine your like terms. You have a 4x minus 1/2 x. Again, 2 would not be part of these because it doesn't have an x. If you have 4 whole cookies and I take away a half of a cookie, that leaves you with 3 1/2 cookies with the variable x. Get rid of those. Plus 2 is left over. Let's look at 10. Combine your like terms. I see a 3 minus a 1 on its own, and then I have two terms that have the value of y, the variable of y. So we'll start with our ones that don't have the variable. So 3 minus 1 would make a 2. Get rid of those. Put down your next symbol, which is a plus sign. Get rid of it. And then 3y plus y would make what? In front of your y, you technically have a 1. So 3y plus 1y makes a 4y. Number 11. In front of my variable x, I have a 1. So we're combining 1x plus 6x. That would make 7x. Let's go on to 12. Combine your like terms. I see w's, and then I see one that stands alone. So we're going to add 5/10 plus 1 7/10. That would make 2 2/10. So 2 2/10 W minus 5/10. Let's go ahead and jump to page 171. On page 171, we're going to pick up with number 18. So 18, 19, 20, we'll go ahead and do 21, 22, and 23. Pause the video to see if the students can find the like terms and combine them. When you think all students are ready, then hit play and we'll check them. Number 18. Let's combine our like terms. So if I look, I have a 5 and a 3. Those are like terms because they don't have a variable. You have a 3W minus a W. So we'll start here. So 5 plus 3 would make 8. Drop down your plus sign. Get rid of it. 3W minus W would make 2W. Remember, there is a 1 in front of that W. Number 19, 5W minus 5W. They're like terms because they both have the variable of W. 5 minus 5 would be 0. And then you have W. So 0W. Or in other words, we have nothing. 20. Side note, if you just said, Miss Holmes put a W there, remember technically there's a 1. And 5 minus 5 was not 1. Okay, moving on. Number 20. You have a 2x plus a 3x, and then you have a 5 and a 6 that are also combined terms, like terms. So 2x plus 3x will make 5x. Get rid of those. Drop your plus sign because it's the next operation. And then you have 5 plus 6 left over, which makes 11. Number 21. You have 3/4 z cubed. You have another 1/4 z cubed. Those are like terms because they both are z cubed, and then you have the little plus 4 left over. So 3/4 minus 1/4 would make 2/4 z cubed. Get rid of those. And then just plus 4. Combine your like terms. You have 3 4/10 plus 2 4/10, which will make 5 8/10 m. And 23, we have 4 2/10 n minus 3 2/10 n. So 4 2/10 minus 3 2/10 makes 1 whole. So you can put 1.0 or just put 1 in, or you can just put n on its own. And then plus 5. Remember, you can't add those two together because 5 does not have an n. Let's look at 24 and 25, and then we'll move on. On 24, remember all my variables have a 1 in front of them. And these are all like terms because they are q to the 5th power. So 1 plus 1 plus 1 is 3 with a q to the 5th power. On 25, let's underline our like terms. I have a 3x plus a 7x. We have a 1/4 plus another 1/4. And then you have a 2y minus a y. So let's start with 3x plus 7x. That would make 10x. Okay, drop your sign, which is addition, and get rid of it. My next one is a 1/4 plus a 1/4, which makes a 2/4. The next sign is addition again. Get rid of it. So now I have 2y minus a y. Remember, technically there's a 1 in front of it. So 2y minus y gives me 1y, or you could just put y. 27A. Use the table at the right. Yolanda is planning a party that will take place in 3 rooms. Write an expression that can be used to represent the total amount Yolanda will need to rent all 3 rooms and the sound system for T hours. Okay, so she's renting 3 rooms. And then it says that she's also renting, hang on, let me go back and check this. Write an expression that can be used to represent the total amount Yolanda will need to rent all 3 rooms and the sound system for T hours. Okay, got it. So when we rent all 3 rooms, apparently every room is a different price. So right now she's renting the first room for T hours. Got it. So the first room is $25 for every hour, but we don't know how many hours she's going to be there. She's going to be there for T hours. So that's 25T plus second room is $20 an hour, so that's 20T plus my third room is $50 an hour. All right, and then if you look over here, the sound system is not per hour. The sound system is just straight up a one-time fee. So first room's going to have to pay $15. Second room pays $10. Last room is no charge at all. Can we simplify this expression? Yes, we can. Oops, I meant to make that a T instead of H. So let's combine our like terms. Okay, all of these have T's. So 25 plus 20 plus 50. Makes 95. So that's going to be $95 per hour. Plus, we can combine these because they don't have variables. So 15 plus 10 is 25. And remember, we can't add these together because 25 does not have the variable T. Number 28. Write an algebraic expression for the perimeter of the swimming pool. Perimeter means that you're adding all sides together. So if you look at the pool, we have a 2y plus a 1. If you notice, the pool is long at the bottom and it's long at the top. So this would also be a 2y plus 1. How many of those do you have? You have 2 of those. So we have 2y's plus 1. Plus, we got to do the sides. Okay? My side is just y. So my side on the left side is y. And it looks equivalent to the right side, so it would also be a y. So 2 times a y, which would be a 2y. On number 29, they want you to actually solve this problem. So let's solve it. We can solve it up here. 2 times 2 would make a 4y, plus 2 times 1 makes a 2. Now remember, you do this because it's the distributive property. It's a number outside the parentheses. Plus 2 times y again makes 2y. From here, we can combine our like terms. You have a 4y plus a 2y, which makes a 6y, plus 2 that's on its own. You can't add these together because 2 does not have the variable y. Go ahead and go to page 172. Look at number 33. Thea said that the expressions 4x minus 3x plus 2 and x plus 2 are equivalent. Is Thea correct? So let's look at these together. You have a 4x minus a 3x plus a 2. If you combine your like terms, you would combine 4x minus 3x, which makes 1x, or just x, plus 2. Remember, you can't add these together because 2 does not have an x. So Thea wants to know, is this and x plus 2 equivalent? She is correct. What would we say? When combining like terms, you end up with x plus 2. Looking at number 34, can you combine these? Okay, let's think about it. So this is a little different. Remember, in front of your variable, you would have a 1. So let's think adding fractions with like denominators. This would be a 4th grade type problem. So 1 plus a 1 plus a 1 would make a 3, and they all had a's, so that's a 3a, over 3 plus 3 plus 3. Because remember, when you add fractions and the denominators are the same, you keep them the same. So you have a 3a over a 3. And if you want to, you could actually probably cancel these and you just get an a. Number 35. On 35 and 36. On 35 it says select all expressions that are equivalent to 8x plus 3 plus 5x minus 2x. On number 36, solve these right here and then see which ones are equivalent and not equivalent. So go ahead and pause the video for the students to finish numbers 35 and 36. When everyone's ready, then click play and we will check them. Number 35. Select all expressions that are equivalent to 8x plus 3 plus 5x minus 2x. So let's underline our like terms. And from left to right, let's solve it. So 8x plus 5x would make 13x. 13x minus 2x would make 11x. And then you have your plus 3 on its own. This is what you're looking for, okay? So looking at the first option, I need to combine these two like terms. So 13x minus 2x would make 11x plus that 3 that's on its own. That matches what we were looking for. If you look at the second option, it's super close, but that 3 has an x. We don't need an x with our 3. My next option, 11 needs the x, not the 3. For the next choice, you cannot combine 11x and 3 because 3 does not have an x. And yes to the last one. Number 36, let's combine these. You have 2x plus 6x minus x. So 2x plus a 6x would make 8x minus, remember there's a 1 in front of it, so 8x minus 1x makes 7x, and then you have that plus little 7 that's on its own, so plus 7. So right now I'll go through these, and it looks like for sure my last one, but look at the second option right here. Remember, commutative property says that like 3 plus 2 is the same thing as 2 plus 3. So if I am adding, I can flip-flop these. So that would also be equivalent. Okay, the ones that were not equivalent were the first and third choices. That is the end of topic 3, lesson 7. When you're done, close your workbook, pass it to the front. Front row friends, go put it on the shelf. When finished, get on your iReady for math. If you see any teacher assigned lessons, you need to work on those to try to get those completed. Remember, they can be taken for a grade. If you are done with all the teacher assigned lessons, then you need to get on your Math My Path.